here's another thing that you should absolutely know. It's the fact that log of a of 1 is equal to 0. Now, why is that true? There's one straightforward proof that simply says log a of 1 is log a of a to what power? Anything to 0th power is 1, right? So you can rewrite 1 as a to the 0th power, and then you can cancel and you get a 0. But there's another proof that I like, because it's pretty fun, is the following. Log a of 1 is log a of 1 over 1. 1 divided by 1 is 1, right? Now, what's the log rule to handle division inside a log?
Subtract.
It's subtraction of 2 logs. That's important. You have to say 2 logs, okay? You have log a of 1 minus log a of 1. Okay. Huh?
Cancel out.
Yeah, you're subtracting something from itself, right? So these two are the same thing, so it's 0. So I like this proof because it's pretty cool. Once you didn't know what log a of 1 is, right? Now you still don't know what the value of log of 1 is, but we know that these two quantities are the same, so you subtract and get 0, and now suddenly I do know the log a of 1. So it's a pretty cool logic. Okay. All right. Now let's think about the graph of logs. F of x equal to log 2 of x, for example. We should make a table for x and y. Let's just choose three values because I don't want to spend too much time. So let's pick 1/2, 1, 2, just one more, 4. As you can see, what I'm doing is I'm picking the values that are 2 to some power. This is 2 to the negative 1 power, 2 to the 0th power, 2 to the first power, 2 to the second power. Okay? And because log 2, 1/2 is 2 to the negative 1 power, if you cancel, you get negative 1 as your y, right? And this will be 0, there will be 1, and there will be 2. In other words, log 2 of 4 is 2. That's easy to figure out. Now let's put these points neatly on a grid. So I'm going to say this is 1, 2, 3, and 4. So this is 1/2. And that should give you negative 1. It's here. And if you plug in 1, you get 0. If you plug in 2, you get... Oh, sorry. I made a mistake. If you plug in 1/2, you get negative 1. If you plug in 1, you get 0. If you plug in 2, you get 1. There's 1. There's 2. And if you plug in 4, you get 2. And you end up with this curve. Okay. And if you continue on by plugging more points, you will see that there's an asymptote here, which is actually the y-axis. Y-axis becomes the asymptote for the log graph. This is the graph of y equals to log 2 of x. And in fact, in general, y equals to log a of x has the graph that looks like this, with this point being 1. And here we are assuming that a is bigger than 1. If a is less than 1, this graph flips. Yeah, but that one you can handle by base change formula, and I don't want to go too much detail with that. Okay? Just remember that logarithmic graphs look like this, with the asymptote at the y-axis, and the x-intercept is always 1.